since that link stuff is going to be a lot of people, I think there's going to be a lot of people gone Thursday. What we might do is kind of push through a lot of this today, and then start some of 12.6 tomorrow, and then kind of between Thursday and Friday, just kind of put 12.5 and 12.6. They're not the same topics, but they're both relatively easy. Just kind of have a little bit of work. I've got one fun thing to do on Friday. You guys will be hypothesis testing one another.
Hypothesis?
Yeah, that stuff. You're going to see whether or not you have ESP.
You have ESP.
We all know that Cullen has it because he knows the cards.
Yeah.
You don't even know what that is, do you?
No.
You never heard of ESP before?
I think I've heard of it.
It's extraordinary special powers or whatever it is.
Isn't it like
So you can read people's minds, you can figure stuff out, that kind of thing. Anyway, let's talk about probability of independent versus and dependent events. You've actually worked with a little bit of this already without knowing you were doing some of this stuff. It is not a horribly difficult topic to look at. Basically, if we look at it this way, if I'm going to roll a die, a normal 6-sided die, if I roll it, I have the probability of how many of them out there? There's 6. So the probability of me rolling a 2 is? It would be 1 out of 6. Now, is this, the second roll, independent of the first roll?
Yeah, it does.
Yeah. It had no bearing. The second roll had no bearing because of the first roll. That's kind of what we're looking at. Okay? It's very, very simple stuff. For example, 2 events are independent if one has no effect on the other. Basically, like I just showed you. And what you're doing is to check the probabilities is you just multiply each individual probability. Okay? So we see this a lot with spinners, or we see that on a die. If I'm going to roll a dice. For example, if I want to roll, probably rolling a 2, then rolling a 3. Yeah. The example I was just saying here is the probability of roll a 2, then a 3. Just 2 completely independent events. What's the probability of rolling a 2? What's the probability of rolling a 3? Therefore, the probability of rolling a 2, then rolling a 3 would be? It's kind of the same idea of when you were working with the, I got 3 minus 2. 3 plus 2. This is why we don't gamble. Okay. In this example here, we have a spinning thingy. I'm going to see, it doesn't really look that great, but you are playing a game that involves spinning the money wheel shown. Gee, what does that sound like? Wheel of Fortune. During your turn, you get to spin the wheel twice.
How nice.
What? Oh. Ooh. What is the probability you'll get more than $500 on your first spin, then go bankrupt on your second?
So many.
It's so many things you just have to count. But do you see where I'm going with this?
Yeah.
It's relatively easy. If I want to sit there and figure out how many places I can get $500,
Wait,
more than 500, so here we go. 1, 2,
no. Yeah, that's 5,000.
3,
4, 5, 6, 7, 8.
5, 6, 7, 8. 8.
9.
Yeah.
9. The 550, right?
What?
Where? I count.
Oh.
How many are there?
You got it.
1 little, 2 little, 3 little spots, 4 little, 5 little, 6. Help me out. 6 little spots, 7 little, 8 little, 9 little spots, 10 little spots so far. 11 little, 12 little, 13 little spots, 14 little, 15 little, 16 little spots, 17, 18, 19 little spots, 20 spots. It's getting old. 21, 22, 23, 24.
I mean, times 2/24.
So 1/12.
Correct.
A
Wait,
number.
Wait,
so when that happens, do you 16 over whatever to 1/16?
yes, or
136. 136.
Es un fantasma. That means ghost for you Spaniels. The what? Oh, okay. Is there a phantasma in there? We listened to the play. I forget what play we listened to, but there was a part in there where they go, "Cuidado!" Ah! And you hear something break. So we just would walk around all the time, dropping books at each other, saying, "Cuidado!" All right, so let's have some fun with this. We have face dye. There are 6 faces on there. So,
I bet all of them are Caleb.
not all of them.
You have too much fun.
I do. So,
What? Oh.
so it's not all about Caleb.
I want Austin's face.
Jenna. I just have to find some pictures real fast. It is. All right, so
Austin Fraser face.
no, I didn't have. I was doing this rather rapidly this morning. So this just keeps. Now, anyway,
So
so
the base like 3. I'll take that back.
the probability of rolling and getting an Izzy and spinning and getting a red.
Is 1 in 6 times 2.
How many? 1, 2, 3, 4,
Does it,
12.
are they independent of one another?
No.
Yeah.
Oh, yeah.
All right, so here let's roll for an Izzy and a red.
Oh.
Oh,
Almost got
That
it.
would have been pretty good.
How about a Caleb and a white?
a Caleb and a what?
White.
Well, there's actually 2
Caleb.
Calebs. There was 2 Calebs. That was what I wanted to throw in there. The zoom out version, and then there's the zoom in version, but they're on different faces. So technically, 1/3 of the die is Caleb. Isn't it? Good to know. So we
I
have
can get you like one more pictures if you want.
no.
In-game ones or?
No. I can get a bow. I should use a bow and arrow to make this spin. I wonder if that'll work.
And white, let's go.
Let's bow and arrow. Where's
Did he even spin it?
Sugar?
That's been cold.
Got her in the butt. That is a pain in the butt, isn't it?
Yeah, that was a pain.
All right, so I can get the.
Oh! The Eagles never do that.
There we go. You don't get. I'm telling you, you don't get this kind of enjoyment anywhere else. I think this is just for me. You guys just happen to be in the room.
I don't think you'll ever get that close of a shot.
You know you practice like after school.
No, I don't.
1997.
He brings his kids here to like throw them the pose.
Yes, 1997 baseball season. The Florida Marlins, the meager Florida Marlins. They were really good. They won 5 out of 7 home games and 3 out of 7 away games against the Giants. During the NLDS, the Marlins played the first 2 games at home and the 3rd game away. The Marlins won all 3 games. Estimate the probability of this happening. There is a lot of numbers.
5, 7, 3, 7.
Okay, hold on, what are you getting?
5, 7, 3, 7. Would you just times them together or what?
Would you do like 2 of the 3?
One
No,
third?
wait. 2
Well-
of the 5s and then 1 of the.
Think about what's going on here. What do we have going on?
We're trying to win 3 games in a row, 2 of them at home, 1 away.
Get 2 home, 1 away.
And what the
You
problem
have a
is.
theoretical, right? So is it 1 out of 5?
Experimentally, it's 1.
1 out of 3?
I got
Oh,
that.
what is it?
Now-
Way better.
During the 97 NLDS, the Giants Stars played the first 2 games at home and the 3rd game away. They won all 3 games. I guess we should say that it's a best of 7.
So,
So then the last one, that they won all 3 of them, so they won 3 out of the what? 3 out of the 7.
oh, so we would.
Yeah, I just realized that I went, that's why I wanted to double check if I didn't click out a line here. But yeah, this was a best of 7, so this should be another 3 out of 7. So the way that, the probability that this could occur, if you just multiply the 3 fractions together.
Wait, how do you get that?
Yeah.
It wasn't given, it was just there, I clicked it and I missed the line.
Actually, I think they only play.
That's all it was.
Is it only 5 games in the NLDS?
I thought it was 7.
They only played 7 in the.
I think it said 7.
Like the championship series and the World Series.
No, except they just expanded it. They just recently expanded everything.
Did they really? Is that like, I don't watch baseball, they don't really play every team into the same game.
If you're in the same division.
In the same division, usually play, was it 18? I think it's 18.
Yeah.
How many games?
162.
162.
Oh my God.
So,
Yeah,
dependent. This is where it can get a little bit interesting. This is where you have to be careful when you read how things are putting out. It's not a
45,
complicated idea
43.
versus, you'll catch on to it real quick here. Dependent events. The occurrence of an event affects the occurrence of another. This is called conditional. The way that they write it is something like probability of B given A. What that means is that A has already happened. What's the probability of that B can happen?
Wait, so
Did you guys do some chapter?
No, we did something that sounded similar to that, like when you know A and
Okay.
oh, is that the one where it's like the stuff where you like do the
The things, the stuff.
No, it's like,
I'm not one to play.
there was like if you know like you have like something on like Friday
Yeah, yes, we did that.
and
Oh.
what
There's,
happens
like,
on
Saturday.
like it's like if some
Yes, yes.
blah blah blah.
Okay.
Yeah, I do remember that.
It's kind of like it's kind of like the law of detachment. I think it's what you're thinking of. Law of detachment versus law of syllogism.
I'm confused, what is the line?
Given that. Given that. For example, what is the probability that I'm going to flip over a 3?
1 out of 52.
Oh, wait, 4.
Or,
113.
113.
113, okay? So the probability that I flip over a 2, and then I don't put it back in the deck.
Okay.
So,
Then I want to get the probability of a 4.
So then you have
4
1
out
out
of
of
50.
1 out of 2.
So probability that I roll a 2, or not roll 2, excuse me, I pick over a 2 is 4 out of 52, correct? Okay. So it's 4 out of 52, and I'm not gonna simplify it right off the bat here. But if I don't place this card back in the deck, the probabilities have changed.
Yeah.
So this is called without replacement. Without replacing it back in the deck, now the probability of the next thing is affected by the first thing. I took one card out, so now the probability of getting a 4 would be 4 out of 51. Okay? That's how that works.
So the B given A is basically just saying you don't replace the last thing.
Yeah, it's kind of, you see it a lot of times written without replacement or with replacement. With replacement, oops. With replacement, the probability of getting a 2 would be 4 out of 52. I put it back in the deck, the probability of getting a 4 would be, it didn't change because they're going back into the deck. Yeah. These are dependent because something changed. Yes,
Wait,
ma'am?
when is the one where you add them?
The adding ones were the one, a lot of times we dealt with, what was that, section 12.3, where you had to we had like at least or at most, when we were doing a lot of like counting things, it wasn't a lot of time, I don't think it was a lot of time with the probability.
Yeah, it's probably.
Okay.
I don't think it was. I don't remember. So the idea here, real easy. You're randomly selecting 2 cards from a deck of 52. What's the probability that the first card is not a face card, and the second card is a face card? If A, you replace it, or if B, you don't replace it. So there's going to be 2 parts to these questions. They're going to ask you for the independent version of it, where you put it back in the deck, and the second one is where you're not putting it back in the deck. So if I want to get the probability of not a face card, well, how many face cards are there?
12.
So how many of them are not?
40.
So you're using the complement rule right there. See how you use the complement that fast? So there's 40 out of 52 with my first, but then the next thing I want to happen is without replacing it, the next would be to get a face card, so what would I do? Okay? What would be different in the next one?
You would do 12 over 51.
And you'll see when you multiply it out, how subtle the differences are. The amounts are just ever so slight. Especially when you're just dealing with cards. They're not that crazy, but you're going to be close. Thank you.
It's 30,
Thank you.
169s, and 40.
Quick for $1 million.
I got you. What is it?
Quick for $1 gazillion.
3 parts.
Try.
Oh, that's the only time to pay them every time you ever.
Sure, why not? We didn't shake that. Gentlemen's bet. Gentlemen's bet. So did you see how the percentages, when you do the decimals, they're very, very close? It was like 0.17, the other 0.18, right in that neighborhood. It's subtle, but there is still difference. Okay. Conditional properties. Conditional probabilities when you get quick for $1 million points. Yeah, all 3 of you guys picked hearts.
And they were like all in the
Well, that's right, it was 2.
All right, so in the next one,
The 13 of
probability
four,
is
yeah,
hard
I
to
would
keep
say
putting
something
back.
So a lot of times what you can do, can't show them the same by the way. When you're looking at a table, you do conditional probabilities rather easily. So if you're reading out the table here, it's saying the number of endangered and threatened animal species in the United States as of November of '98. This is well up to date, ladies and gentlemen, well up to date. Find the probability that the listed animal is a reptile, and B, the probability the endangered animal,
It's a reptile.
find the probability that a listed animal is a reptile.
And the probability that an endangered animal is a reptile. It's different. So like basically what you're saying is
Any animal.
any animal
Oh, okay.
besides a reptile, like you don't
Gotcha.
do that one.
So just pick.
No, I know, but I was gonna say you don't do
I thought like, did I cut something out when I put that in there?
It's a reptile.
It is a reptile. Well, I don't know about you. How many reptiles are in the table?
35.
How many?
It's a reptile.
How many are total in the table?
267.
Is it 267 for all of them?
No, you gotta add all of it.
I did.
All of the numbers.
Oh!
All of them already.
Oh, I didn't know that.
Yeah, some of the tables I think we worked with actually had a column that said total.
Yeah, that was nice.
It was nice. This is making you actually press buttons. I'm
Yeah,
sorry.
I know. This is a tough life.
Thanks. You're the best.
What? 475.
Oh,
475. So the fact that we have 35 out of 475 are reptiles.
That's
That's part-
0.07368422105.
Okay, show off. Now the probability that the endangered animal is a reptile. So not only is it saying that you want it to be endangered, given that it's a reptile. That's basically what it's doing.
0.0294736.42. With the fraction what we do?
No.
Yeah, just
Maybe. So, what did you get for that also calculator, man?
0.029473.
Otherwise, it was 14 out of 475, right?
Yeah.
Wait, would it be like the endangered animal, so you just have a top collar?
That's what, it was just saying that it was, or the endangered animal is a reptile. So,
Yeah, so you would take the top collar.
Wouldn't you like only take out?
the endangered animal is a reptile. Hi, I need a card. Yes.
No, I think he's doing it.
795.
All right, let's flip this at the head.
Should I shoot it?
Do it. Shoot it.
All right, ready?
Wait, are we doing it again?
Oh,
Everybody did the heart.
Are you putting the heart on? If you did that to the next one, I probably would be a heart, and it hasn't been called.
It was a jack of clubs.
Yo, I bet
Now-
that's a heart.
Oh, you know what? We read this wrong.
What?
For what?
what is it?
Oh yeah, I will.
You do it right now.
So the probability that the reptile,
326.
given it is endangered.
So it's 7.16
So it's asking. We just asked about. Instead of being all animals, it made it more specific. Probability it was a reptile, given it was. Bless you. Given it was endangered.
Here, let me see a bow after.
So the 14 out of that is
Yes.
It's 322.
So we read it wrong. It's 325. I need a coin for the people that were just.
I got maybe.
I'm lucky.
Oh yeah, I did.
It made.
Actually, I actually forced it.
I want to rocket, that's why I was.
All right. So it's heads and tails. For those of you guys that just took it, ready?
What if it's not either?
Tails.
Yes!
You guys all picked tails.
Can I not get my tails back that I picked from our test?
How many?
Nah, I got that.
No!
It's my flip. Cannot show the arrow.
Don't dry fire.
There's not much to 12.5. There really is not.
I could have done it on the sheet I just turned in
We
too.
probably could have.
What are you doing?
I'm gonna stray away from the combination style ones of these right off the bat to start today. I forgot what page this was.
Katie should like this and I'll grab it.
Yeah, why are you holding it in the middle of the bow? You should hold the back of it.
But I feel like I get more better aim when I do it like this.
I'm getting out of the way.
Can I try?
Dude, that there was no wall there. That would have gone such a far away.
If she was on a cliff.
Such a far away.
That's a thing to say, bro. Such a far away.
Hold on, in the snow.
It's better.
All right.
Hey, Joe,
Let me show you my archery skills. I'm on the archery.
We used to have archery in gym class when I was in high school.
That sounds
Really?
like
That's dangerous.
Just asking for something else.
Yeah.
You know how their kids like
He said ball.